Hello, everybody. This is session number 45. One of the important session that we are going to discuss today is a data fragmentation, which is continued session from the previous presentation. Now, in this presentation, we'll extend how the data fragmentation needs to be there and what are the various fragmentation techniques are there and how the fragmentation we really to be carried out by using a different techniques. So the basically when we fragment, there is an important concept that we need to deal is fragmented data is always an imperative way to handle in a different situational and organizational needs. And when we fragment the data, so we have to identify what are the different ratios or what are the different scales that we have to maintain. And these fragmented data has to be put into reassembly so that we can read it once again. So the important concept in the computer network is a data fragmentation in various aspects of data fragmentation and how exactly reassemble to be carried out in a further extension of the previous session. Now, what is an IP datagram? In the last sessions also I have clearly explained as when IP datagram initiates the process of requesting the data transmission, here we have to carry out the different formal concept. Here the unit of IP data which is delivered called the datagram. So datagram constructively what happens here is when you carry out the different header notations to carry the content-tree way of transaction which carries the payload to the destination, there is a different aspects are concerned. One is what are the various fragmentation that is there in the header file, and it may includes header area and the data area, which is already we know the facts of IP datagram. Here we have to think what are the elements, what are the constructive elements in the header and how these constructive header elements will be carried out, which may be further analyzed that based on the data header your rotations of a data packets is it depends. Of course, data area is equally important because these data area in other way will transmit the load into a destination. That's what the data area is also associated with the header file. Datagrams have a different sizes. Please remember, in the last sessions that we have discussed that data headers or the data datagrams has an equally important for transmission over on the octets of different IP addresses. But in this case, there are the different sizes in the datagram it is concerned. Header area usually fixed as a 20 octets, and these out of these 20 octets, there's a different options to include, and beyond that, the header will not. It will automatically discard the characters. Now, in this 20 octets, it has to always initiative to consisting or containing all the data in the standard format. So further, data area can contain between 1 octet to 65,535 octets. This is 2 to the power of 16 data elements of data octets in the IP datagram. Okay. Now, what exactly this means? The header has a different standards, and header consists of different octets, so that it includes different aspects of it, and each data area in a randomization or in a further classification that we can know that data area has a payload of different aspects. Now if we include an header, we have to list out and make a checklist that what is an important element that data header is carrying and how each header point has indicative the respective the data area packets and other things. So here the header will generally includes 20 octets consisting of size, length, and other vertical parameters and other characteristics parameters. So what is a fraction of identity? What parity of data is been there? So there are so many parameters which we need to identify the structure of header. Now the data area include is completely a quantumized data which we are going to carry in the transmission. So data area is a very important. This is a very wide scope for calculating the triggered header file, trigger the data on the transaction system. Usually data area is much larger than the header. Why? The basic question. Sometimes what happens here is when we say that there are the 20 octets, and in one octet it is carrying a payload, but in a 20 octets it can have a different dimensional elements, which is very important for the transmission is concerned. Because if your header is a clearly indicative, then the data packet transformation becomes a simple. Okay, so how do we forward the datagrams is a very important, because we cannot isolate them unless there is a standard way of forwarding the datagrams, right? So these datagrams, the header contains and all the information needed to deliver a datagram into a destination computer. But what exactly the header contains? Here the discussion is when the header is a comprehensively designed, when the header is comprehensively contained in all the information which is beautifully associated with the data payload, then it is necessary to know that what are the parameters that we need to identify in a header section. These are common parameters like a destination address, source where exactly it is being generated. In the destination address, it is necessary to mention the machine code, MAC code. In the source address, also it is necessary to mention the MAC code. And each datagram is been identified by individual identifier and other delivery information which needs to be transmitted in a general structure. And of course, there is a standard parameters that we always deal with, how these parameters are essentially component in the form of a transmission. Now, routers examine the header of each datagram and forward the datagram along a path to a destination, and use a routing table to compute the next hop before transmission may occur. Now, these are the routing tables and address marks. In practice, destination stored as a network address. So this is a very simple and precise way to handle our transaction mechanism in a network. See, I'll tell you what happens here is there is a simple next hop address IP is to mentioned over the router, and address mask defines how many bits of address are in prefixed. For example, class A mask is 255.0.0.0. This indicates the MAC address of this thing. Now what happens here is, if you look into this, here we need the certain subnet, like this particular router, this particular, if you identify this, see what happens here is this router has a dimensional ability to read and a readdress to a next MAC code, so that this 30 divided by mask stuff by 8 to be transmitted with another set. Here the reinitialized data to be transmitted with this. So here one more router is placed before it get transmitted to another site, and the third dimensional router is also being placed over here. All right. Now what happens here is, when you have a destination to be mentioned in the header, it is necessary to protect and provide services to the mask with encapsulating the mask, so that next hop automatically detect through this mask. That's a very important here. Similarly, this particular second bit of destination is masked with this thing, and it is been directly delivered. This is called the delivery direct. So here hopping is not created. There is a free channel for the transmission, so it does not take an help from the hopping. Automatically is jump to a direct delivery of a system. Okay. Now if you look into this, this is a routing table for the center router. This is a table consists of destination, mask, and the next hop. As we know that there is some different destination marks over here. This means that different IP packets we are trying to, different IP datagrams we are sending to multicasted these IP machine addresses and masked with Wherever the possible are there, we created taken a help from the hop. Otherwise, there is a direct delivery to a data packets, right? Okay. Next important discussion here is address mask. How do we do an address mask? Okay, so that these addresses will not be visible unless it is a proper authorized person to visible the address mark. To identify the destination network, apply the address mask to a destination address and compare to network addresses in a routing table. So it can use a boolean AND operation. If a mask of an I, see again I just want to identify here. So what happens here is, I'll tell you, the simple way is we are using the control statement to check logically. If mask of an I and D in a destined elementary structure is equal to a destination of Ry, which has been mentioned in an address to be forwarded. Okay. Now, this is an important symbol. Consider 128 wala. So this 128 1.15.26 under the router. So this means that this condition is verified as definitely then address location is right, then without any this thing, without any wait period, it is been forwarded to the next topic. So in the second router we have not sent it here. If it is second router, there is another filtered packets over here where these datagrams was to be cross checked, so that if these cross checking elements are compared with the same if conditions, then we'll follow the simple mechanism of carry forwarding to data packets, right? So this will illustrate how generously that we use an address mask to identify the transmission of that particular set. Now forwarding the IP packets. So there is a destination address in IP datagram is always an ultimate destination. Many of us we know that IP datagram is a clear indication of it consists of internet protocol which enables to read the datagrams in a continuous manner without hesitating to any classified data packets. It generally reads whatever it comes on the way to read it and implement and carry forward it. So destination address in IP datagram is always an ultimate destination to transmit it. This is a one way to indicative references. Now I'll tell you one more important aspect here is, as we know that IP datagram is always an ultimate destination, this means that how many times that we keep analyzing our process that the address mentioned in the header is appropriate. This is we call as a pre-synthesize or pre-analyze them. So once we pre-analyze them, there is an always we have to create a virtual table, and once we analyze that virtual table will be carried in a definitive task, and wherever we carried that also maintain an accountability in encountered table. So this is very important. As why I am telling this virtual table is an important, the reason here is when you start reassembly or when the packets are transmitted to a destination, it is a necessary to read it out and understand whatever the data packets that you are trying to send should be visualized at another end based on the table. Suppose if you lost some of the datagrams in the transmission line, it is very difficult. Then with the help of this virtual table, we can easily trace how which particular data packet containing the address of it we lost. This is called the cross validation, or this is called what you call the rebuilding the datagrams. In a rebuilding datagrams, in the sense, if any of the data which you lost should be built on the basis of data transmission. And the network interface layer takes the two parameters. One is an IP datagram, another is next hop address for a transmission. This IP datagram is, as I said, equally important because it has only the two parameters. One is header address, another is a payload address or the payload, data payload. Now this address is a very important. In case if does not have the free channels to be transmitted, then we have to take a help from hop addresses. Next hop, right? Next hop addresses never appears in an IP diagram, but it only logically happens in the router and other equipments, which is very important. This is called the statistical approaches, and these statistical approaches in a carry forwarding creates a number of parameters in the transmission line. Okay. IP is the best effort delivery, as I know that IP provides a service equivalent to local area network. But here, as I said, it is of course in the last session that I am repeating once again. The reason is it does not guarantee to prevent duplicate datagrams, a delay or the out of order delivery, or the corruptive datagrams can be filtered out, and reliable delivery provides by the transport layer. So next important here is how the IPv4 datagram format looks like. I'll tell you one of the IP protocol version in the header. Look into the header. IP protocol version number, which particular version that you are carrying, what is the head length. So normal version is a 4 or the 6. Header length consists of 32 bits, and the type of service, whether it is a data or the flags or the bit parity or anything, the type of service. Total length is a total datagram length in the form of a bytes. 16-bit identifier, this is flags, 16-bit identifier, and a fragment offset. Everything we call as a fragmentation, and this is used for fragmentation. This is a very important. I am underlining here this particular set. We use it for fragmentation assembly. And time to leave, this is a very important. Maximum number remaining hops are decremented at each router when it passes. So this is a timestamp in which your data is been supportive, and upper layer and the internet checksum. These two, upper layer and the checksum, this is we called process execution. This is called a process execution. This is called process execution. Now, in a 32-bit destination IP address has a different varieties of it, and each time when the option is to be carried out, for example, here a timestamp, record route taken specifically, all these things are important. Now, if you look into the data variable length, typically a TCP or UDP segment, user datagram protocols or the transmission control protocol, you have a variable length. Okay. Uh, Either it may be static, still it is a variable length. Even though if it is a dynamic, still it has a variable. The reason is static and the dynamic. The reason is sometimes it will capture an exact static data. It doesn't change. But according to the situational arrival, this particular variable may dynamically X for the changing. Okay. And here a timestamp, as I said, records a route taken a specified list of routers to visit. This is simple way to identify how much of data that been transferred, taking a duration as a count, how many seconds of time it has consumed for the transmission, which we have to include here. Okay. Now next is one more important here is parameters that we need to consider. Destination address, the MAC address and the IP address has to be maintained. Next is upper layer protocol, which may be a recipient, example TCP IP and other IP protocol system. We call it as an upper layer protocol system. Type of service, specify the treatment of data that you need during a transmission through a networks. It may be a smaller, or it may be a bigger, or a unit transformation is always necessary. Either it may be a local area network, either it may be a wide area network. It has to always necessary to maintain. But sometimes there may be many routers which ignores a type of service. They said it is a data of course by default it is a data transmission. I agree with it. But sometimes what happens here is, if you are carrying only the voice, of course payload doesn't treat or discriminate the data in the form of a text or the numbers, or a data form in the form of a voice. Everything for its consideration, it is only a pure form of bits and bytes as a pieces. But it is necessary to check what kind of a data that you are going to carry out. Now, identifier uniquely identifies a PDO for a particular sender and the receiver, which is need to be addressed in a standard way of handling the tricks. So it is needed for reassembly and error reporting. One more parameter that we need to address here. Send only, that is sending a data packet not used for delivery as an acknowledgement is a very way. So these are the parameters. If acknowledgement is delivered, this means that data packet is delivered to a destination without any disturbances. Now we move on flags which uses a 3 bits. What is a flag? It's a simple way to indicate yes or no. Logical importance is given here. If it is yes in the sense, yes, there is a fragmented. There is no fragmented, flag indicates no. So flag will give you an idea about if it is fragmented, how many number of fragmented data has a connectivity. Because once the main chunk of a data is been fragmented, this means that header is repetitive along with the data. Say, as I said in the last session, that there are 24 means 8 bits of octets has a 3 frames, data frames. Okay, so first, is this data is fragmented? We have to cross check and create so identification of yes or no. Second, are we allowed to fragment the data? If it is yes, that we can fragment. If it is no, that we have to send it, otherwise reject it. There is no other go. If the data packets which is not allowed to a fragment and the system is not allowing, then straight away the data packets has to be rejected back to a sender. Okay, if not, may not be possible to deliver. This is a very simple way of handling the disk. Third is it is not used. Checksum is not created because these flags are say no. So third, it not be created. Time to leave. It prevents a datagram from traveling forever by decrementing each hop in the sequences. And each header length in a group of 4 bytes carries some important information. And the total length in a bytes includes a header and the data. As I said, it is very simple. And optional data, there are sometimes an optional data which indicates how systematically these data parameters are used to handle, even though if it is a very technically difficult situation. So all your data streams to be handled in a systematic way of it, so that the recipient side should not be raised any problems that the loss of data packets. That is, we have to maintain for the longer term of durations. Now, there is some type of services. It might be useful for different traffic. For example, if you take an ICMP, here internet connection mapping protocols are ICMP, where here we need to know that what time the server becomes a responsive and what time the server does not respond. So ICMP is generally a management protocol which maintains how to handle and manage a responsibility and identify how many equipments are the stakes. So in each stake, it is necessary to identify what are the different services are included in that. This is how the simple ICMP will take care of managing data, or the real-time data, or the non-real-time data, or the virtual data, or the fraction of data. So these are the things that it will carry out. Now in the precedence level, there are the 8 levels. Okay, so timing it is not required, so go in depth of understanding. Just you need to remember these are the type of services that we have to encounter in a transmission with the help of a datagram: reliability, delay, and the throughput. Next, we move on to a next important thing. Here is there's some more options, like where a datagram need to be used rarely, way to extend an IP protocol with a variable number of options dropped in IPv6. Security, source routing, route recording, stream identification, and the time stamping. Since this is an optional where it means that header can be of a variable length, so whether you need to maintain it or some of the router can avoid, or sometimes some of these things may be avoided. This is why we need to the header length to be filled. If an IP datagram has no option, then the length of that can be a 5. Header with a 96 bits of option, then a header length will be an 8. So this is a very important in many situation. If it is indicative of a 5, this means that there is no options is to be included. Well, I hope that you are getting an idea about how the things it happens as per the technical flexibility is concerned in the data communications. So you may be understood that transmitting a bit of data, what it requires, only the wire, physical computer get connect and transmission. No, there are many technical, there are the many technical hard work will go in understanding these things. Well, datagram lifetime. Datagram could be loop independently. It consumes the resources. So transport protocol may need to be upper bound on the datagram life. Datagram marked with a lifetime, which includes like a filled in an IP process. And once a lifetime expires, the datagram discarded, not forwarded, hoop count, and the time count. These are the datagram lifetime in the transmission process. Data filled, which is a very important. Here it carries the user data from next layer up. It likely UDP or the TCP packets. It integer multiples of 8 bits with a long octet. Maximum length of datagram. Header plus data includes 65,535 octets. Octets is an 8-bit. It's called an octets, right? So datagram transmission in frames, IP internet layer. It includes the responsibility of construct the datagram, determines the next hop, hands to network interface layer. Network interface layer is concerned, it binds the next hop address to an hardware address and prepares a datagram from transmission. Well, I listed out these things. Well, these points which you need to remember. How do you remember? These are the service techniques. So many of we know that IP internet construct a datagram. No, it does not construct the datagram. It construct logically. There are some basic addressing methods. That's a very. It does not creates an unit. Units are already there. It binds it. It assemble it. That is a very important. But hardware frame doesn't understand an IP. How is a datagram transmitted? This is a very important question. I always understand these type of a technical aspects we need to discuss in detail. See, hardware frame does not understand IP. Then how is a datagram transmitted? It's very simple. When you transmit this particular datagram, your destination after assembly, it will take care of your physical layer to further whatever the data that you have mentioned should be authenticated and transmitted to an authorized location. That's a very, very important here. Okay, we need to remember how the encapsulation happens here is. So network interface layer encapsulates an IP datagram as a data in which the hardware frames are relevant. And these hardware ignores an IP datagram form because these are some standard data formats. And these standard defines a data type for an IP diagram as well as in others, which is very important. And receiving a protocol stack interprets the data area based on the frame type are one of the important. As we know that if you extend here, what happens here is frame header to an IP header has a correlation, and data area to frame data is also relevant. Okay, now this is a you go back to the previous slide here. So on the 17th slide, this is an encapsulation across the multiple hops. Each router in the path from the source to a destination. So here encapsulates incoming datagram from frame to frame has to be created as encapsulate datagram in outer going frame. And datagram may be encapsulated in a different hardware format in each hop. This means that it is necessary to encapsulate the process and read out in a systematically for the before creating a next hop. This is the IP fragmentation and the reassembly, where network links have max transfer size, maximum transfer unit, largest possible link levels of created frames, which are different link types and MTUs are there, which takes a responsibility of transmitting. Then at the reassembly level, only a final distinct items has to be reassembled, which bits used to identify the order related fragments needs to be understand. All right. Next is a fragmentation and reassembly. If you want to reassemble a destination, it results in packets getting as smaller as a data traverse internet. And why not reassemble in an intermediate router? The reason I'll tell you. This is a very good discussion and very debatable issues. When a data packets are transmitted from a source to a destination, so why can't we do a reassembly at no reassembly does not have any impact. The reason behind is, if you start reassembly, one is it is a time consuming process at the mid of data transmission. If you start reassembling, what happens if you lost are the some late arriving packet to a destination, then here it will create an error. If this will create an error at the destination, again there is a sort of a error. Now we cannot do a reassembly in the mid of data packets. Why not a reassemble at intermediate routers? This is the reason. You need the large buffers at a routers, and it buffers may fill with the fragments. Then it is a time consuming process. All fragments must go through the same router. Then if you start what you call that reassembling at intermediate routers, it is a collapses and other fragmentation to be transmitted at the destination. That's why reassemble at the intermediate will not be possible in the routers, and routers have enough work to already done without having to reassemble the stuff, right? So IP fragmentation, IP reassembles at a destination only, use folds, and these are the important points which I have already explained you in the larger scale of implementation. This is a IP fragmentation, and the length is this, all the stuff. It's the same thing what I have explained in the previous sessions. Now this is a fragmenting part of this. Rotor fragments at a fragmenting to fit. Resulting fragments, look at just original fragments. No need to reassemble hierarchically, and other things are there. Now this is dealing with failure. Reassembly may fail if some fragments get lost. So I'll ask you one question. Maybe you people are completely involved in know how these datagrams can be transmitted and how these datagrams generally. So you do a lot of simple projects. There's a lot of experimental projects which are there on available network. You need, what you need is connect one system to another system, one PC system to another PC system, and start identifying their machine code transactions. There's an IP transaction system, and take some similar software projects which you can freely download from an internet. See that how these data packets are been transferring, you can easily trace out, and these data packets which we are trying to transmit has a direct impact. Okay, so you can do a small downloadable data free softwares are there to know how the data packets are to be transferred from P2P network. So you don't think about a large area of a networks, communicate one system to another system, know how the transaction is being carried out. Okay, now we conclude this session over here. Hope you understood that the extended form of IP datagram and other factors involving this. Please keep reading and keep watching. It enhances the reading facility, and visit continuously all the materials, MCQs, and video contents in an LMS. Till then, till then, the next sessions. Have a good time. Have a good time, and thank you very much.